Great. So far we have seen the first three, right? We've seen how to hydrate, number one. We showed two, how to reduce aldehydes and ketones, and then we show how to reduce the carboxylic acids and esters. Nothing complicated at all. There was nothing complicated. Now we're going to look at the last three. So in the last three, here's the thing. We are looking at number 3, 4, and 5. Okay. Right. Now let's go number 4, 5, and 6. I'm sorry. So the fourth one is going to be, let's say this. It's going to be the reaction between your haloalkane and your base. So should I say addition of base, or let's say substitution? Huh? Okay, but what is it? Haloalkane with base. Haloalkane. Okay, haloalkane with base. Okay, haloalkane with a base, like NaOH or KOH. Okay, KOH. You need a base. And this base has to be aqueous. So should I say aqueous base? Okay, with aqueous, because it has to be in water. With aqueous base. We can call it an alkali now because it's dissolving in water. A base that dissolves in water is called an alkali. But let's say just say aqueous base. NaOH or KOH, whatever you see. If you see a haloalkane meeting NaOH or KOH, just know this. Group 7 freaks out when he sees an OH. Okay? And he runs away and leaves the OH to take that position. That's always what happens. Anything from group 7. So what is it? Let's say we have something like this. In here we have a Br that is just connected to your alkane. So basically this guy has carbon 1, 2, and 3 carbons. Okay? Then he's connected to a Br. If we mix him with NaOH in water, aqueous, so we can put water on top of our thing, or we can just put aqueous here. Okay? Another way. So normally if in the slides you see it as water here. So now what happens is whenever we do this, what happens? Br is going to run away and leave OH. He is always removed. So what's going to happen is we have like this, and this is going to be NOH, right? And we'll have as NaBr. So that's going to happen. That's what's going to happen. And this is the reaction. So in here, what did we have? This is 1, 2, 3. So it's a propane because it's an alkane. But because there's a bromine, we'll put it as 1 bromopropane. Okay. Then what is it going to have? Okay, so in here, instead of water, you could have put it as H2O, same thing. Now what you have is here you have an alcohol with 1, 2, 3, which is just going to be propanol. Okay, and it's 1 propanol because it's on position 1. It can be here at the center on position 2. Okay, it's position 1 if you're counting from the right going to the left. So this will be your 1, your 2, your 3. So it's on position 1. Now that's it. And that's what happens. Now let's go to number 5. Number 5 and 6 now, we are making phenols, okay? So we are actually now making a special type of alcohols which are called phenols. And phenol is when you have your benzene ring, something like this, okay? 1, 2, 3, 4, 5, 6, yes, and something like that, okay? So then what you have is here, you now put your OH, and that is what you have as your phenol. So number 5, how are we going to make it? We are going to make it from haloarenes, which is the same as haloalkane, but here the halogen is on an arene. So instead of haloalkane, where you have the halogen on an alkane, it's going to be on an arene. So on our benzene ring. Now let's put it 1, 2, 3, 4, okay, 5, then 6. Then in here we are going to have a group 7, Cl, right? We put our things like that. This is the thing, the structure. Now, if we add NaOH, we know what's going to happen. We know what's going to happen. This group 7, when he sees your base, okay, what does he do? He freaks out and he's going to run away. And you're going to have OH there. But now, this is a 2-step process, okay? This is a 2-step from haloarenes, okay, which is a group 7 on our benzene. It's a 2-step process. And both of the ways we make phenols are 2-step processes. So here, we are going to have, this is one of the only reactions, this one and dehydration of alcohols, which is the first reaction on how alcohols actually react themselves. These are the only 2 reactions in alcohols that actually have conditions. In here, you need to know the condition. This haloarene one, So the first step is 623 kelvins here, and you need to know about 300 atmospheres of pressure. And what are you going to get? What's going to happen on the first step is this, is that you're going to have your Cl go, yes, and that Cl will meet with this H, and we'll have the NaO go there. Okay, that's going to happen on the first step, but we know what's going to happen on the end at the end of the day. But first, let's put that. So what happens in the first step is you have it like this, like this. Here, what happens is ONA is coming, right? Who has more bonds? It's oxygen. He's the one that can bond, so it will be ONA, right? But this is an O minus Na plus. Okay, now you formed a salt. Then what happens in the last step is now you react this with the HCl, because this H will meet with this Cl and become an HCl, and it's going to now react in the second step. And what we are going to end up having is we exactly know what we will have. We are going to have an alcohol. So this becomes an OH. You're done. That's how you're going to do it. So these are the steps. Now, number 6 is going to be, they say from diazonium salt, okay? They say that you are now forming from diazonium salt, which is true, but diazonium salt is an intermediate, so I don't want you to do that. You can say it is from anniline. That's actually where we start, okay? I know there's diazonium salt, but we start at anniline. So let's put it. What is anniline? It is an amine where you have your benzene ring, okay? And then on your benzene ring, you have the amine. This is the amino group, what makes it an amine. So it's an NH2, sorry. Okay, it's an NH2. That is what makes it an amine. So anniline is an amine, okay? Then what are we going to have? This guy is going to meet, okay, we normally write it on top of arrows like this. That's where it is written. He is going to meet two guys, and these two guys are NaNO2, sodium nitrate, like this, and you are going to have hydrochloric acid, because these two guys make a special acid called nitrous acid, HNO2, and he is the one that's going to attack the anniline. But look at what we write. Anniline is a base, okay? So he's going to react with an acid. So I'm going to make it easy for you. Anniline is a base, is going to react with the acid, and we know the acid is actually HNO2, which is made by these two guys. But let's just do it this way. Anniline is a base, yes, so he's going to react with the acid, which is hydrochloric acid. So what's going to happen? Acid plus base, what do you get? Salt plus water. So let's put it. Look at how fast it's going to be. Here's our anniline. Is now going to be a salt plus water because it has met, it was a base, now it has met the acid. So what's going to be a salt is going to be N and Cl, right? Okay, because N is going to be positive, then you need to take the Cl, N and Cl. But look at what we do. We make this an N2 so that it becomes a positive, and we have our Cl minus. Here it is now a salt, straight up. So now when it's a salt like this, this is what they call the diazonium salt. And this salt is called benzene. That's the diazonium, huh? Benzene diazonium salt. That's the one which we want. Now this guy, who is he going to meet? He is going to meet HCl. Again, just like the second step was HCl. Okay, no, he's going to meet, he is going to meet water, warm water. You always warm it up. Okay, you just mix it with warm water, and you are going to get your alcohol. Whoa, that was a bad error. Anyway, he's going to meet with water, and you get your alcohol. That's going to be the last step. Okay, where you just warm it up in water, this diazonium. So the reason why they like it, if you see, they'll say that warming diazonium salts in water gives you an alcohol. So that's just what happens. Now here you get your water, and you can release your nitrogen, N2, and you're going to get hydrochloric acid as your byproduct. So this is what you're going to have, and you are done. So here what happens is you now warm it up in water. So don't forget this. You have NaNO2. If you can remember this, then you are done. NaNO2. Okay, remember NaNO2 and HCl, and remember that what actually happens is the HCl reacts with this guy. That's what we say, and then the Cl will go, the Cl minus, and it is now going to meet with the N and become a salt, N2Cl minus. And then what actually happens is on the stage 2, we just warm that up with water, and we are going to get this alcohol, okay? And what do we have? N2 and HCl as our byproducts, and that's going to be the end. That's it. You're done. And these are the 6 reactions that you got to know. Nothing complicated. Here we mix it with NaOH just like we do on here, on this step, NaOH, right? Remember that. And in here we are going to get a salt where the NaO goes, where there is the Cl, and it becomes O minus Na plus. Remember that is the O that goes to bond to this bond here, okay? And this Cl flies off to H and becomes an HCl, which reacts in the second step to change this O minus Na plus to an OH, basically. Now here, that is what we had. We had our NaNO2 and HCl. They react. What do we form? A salt. Warm it up in water. We make our alcohol. That's the end, and you are done. That's all you gotta know.